On the top of this slide here, I've written down the general form that all absolute value graphs will take. The h and k that you saw in that last video are kind of the common notation used. H is typically used for the inside right here, and k is used for the outside. And we've discussed what each of these variables does. The h on the inside controls your left-right movements, depending on if we're adding or subtracting a number. And the k on the outside controls your up-down movements. The thing that we haven't focused on yet, and that will be the focus of this video, is talking about what happens when you have a number being multiplied on the outside of your absolute value. So this a out front here. As it turns out, a will control the slope of your raise. And I'll explain what that means as we go through a few examples here. So a is going to be impacting our slope, or how wide or narrow our graph is. On my first graph right here, I have 3 times the absolute value of x. The first thing you should always do when doing one of these graphs is figure out where the vertex goes. You've got to find that vertex. So we're going to look at how it moves left, right, up, down, and we'll see where that vertex gets placed. There's nothing being added on the inside. It's like a +0 there. Don't go left or right at all. There's nothing being added on the outside. This graph doesn't go left, right, or up, down. So the vertex stays right where it was at 0, 0. Now typically what I would do is I would go up 1 over 1, make my point on either side, make my v, and be done. But here I have a 3 on the outside, or if you want to think about it, 3 over 1. So instead of going up 1 over 1 and being done with it, I'm going to go up 3 over 1. And I'm going to do that in each direction, up 3 over 1. And that is how I get my other 2 points. Notice my original absolute value graphs are a little bit wider than the one that I got. Maybe they're like this. This graph has been kind of compressed using a vocab word from up here. It's like we took the graph and we squished it together a little bit more and made it a little bit wider. Or sorry, a little bit narrower. So this is our graph. It grows quicker than the other ones. As a side note, or not really a side note, but just as a comment on this, when we were graphing things like absolute value of x by itself, it's like there was a 1 out front that we didn't even bother putting. So if there was a 1 out front, that's why we went up 1 over 1. Here we have a 3, so we went up 3 over 1. On my second example here, I have the absolute value of x divided by 4. That's the same thing, remember this is like a 1 out here, as 1/4 times the absolute value of x. When you divide by a number, it's really multiplying by 1 over that number. So that's the same thing as 1/4 times the absolute of x. We don't go left or right at all. We don't go up or down at all. It stays at 0, 0. But my slope says I need to go up 1 over 4 in each direction. Up 1 over 4 puts me right there. So I get a really wide looking V on this one. So if you look back at what I said here, the slope of the rays, remember from geometry, a ray is like a half of a line. It goes on forever in just one direction. The slope of this piece is 1/4. And the slope of this piece is technically a negative 1/4, but still use that up 1 over 4 trick. The last example is kind of tying together everything we've done in the past 2 videos. We've got movement going on, and we've got a number out front. So the first thing you always do is find the vertex. You need to find the vertex first. If you don't know where that goes, you can't figure out where the slope is how the slope's gonna take over. So my graph moves left 1, down 3. So I'm going to go left 1, down 3, and I'm going to put my vertex right there. Once your vertex is in place, all we need to do is figure out the slope. This one is a -2, so I'm going to be going down 2 over 1 in each direction. So I get 2 points right there. My graph's probably going off screen. Let me check that. Yeah, it's a little bit too far. I got my vertex. I went down 2 over 1 each direction, made my points, and I got my graph. So when you see a negative out front, that's probably worth writing down. When a is negative, another way of writing that is when a is less than 0, it'll be an upside down v. And that's how you graph an absolute value.